Hey Ramblers! Tonight's video covers chapter 7.2 in our textbook and deals with two theorems, the no-choice theorem and angle-angle side. No choice is really a method of proving two angles from different triangles are congruent. And while it doesn't seem all that useful, it really provides the basis for angle-angle side, which is yet a fourth way to prove two triangles are congruent. So we can add it to angle, side, angle, side, and side, side, side. So please take careful notes tonight, and I hope this helps. The no-choice theorem proves that two angles in different triangles are congruent. Now the triangles don't even have to be congruent. One triangle could be what we'll call similar to the other. If we know that angle B is congruent to angle Y, and that angle C is congruent to angle Z, no matter how I manipulate the measures or the shapes of the triangles, so long as the angle congruencies remain intact, then I can be assured that angle A is also going to be congruent to angle X. And sure enough, no matter how I move the different triangles, angle A is always congruent to angle X, so long as I know that the other two angles of the first triangle are congruent to the angles of the second triangle. Now why is that? Well, the proof isn't very difficult to follow. I know that angle A plus angle B plus angle C equals 180 degrees. So therefore angle A equals 180 minus the sum of the other two. In the other triangle, angle X plus angle Y plus angle Z equals 180. So angle X equals 180 minus the sum of the other two. Since we know that angle B is congruent to angle Y and angle C is congruent to angle Z, I know that angle A must be congruent to angle X, and that's called the no-choice theorem. You don't have to write a lot out. You can just write no choice. All right, let's see how this provides the basis for our final method of proving triangles congruent called angle-angle side. Angle-angle side is the fourth way to prove two triangles congruent. And the requirements are that two angles of one triangle are congruent and the corresponding side. Now, let's be careful with this. We know that if we had the side between the two angles, that will be angle-angle side or angle-side-angle, and we showed that to be true throughout the first semester. But here we're given a corresponding side, so it has to be in order the two congruent angles and then a side. So if it's the side opposite the larger angle in triangle ABC, it has to be the side opposite the larger angle in triangle XYZ. If you tried to call this angle-angle side, it's not valid and it wouldn't work. So you have to be a little bit careful with angle-angle side. Now, how does the no-choice theorem fit into this? I mean, why does angle-angle side work? Well, because of the no-choice theorem, I know that if angle B is congruent to angle Y and angle C is congruent to angle Z, by the no-choice theorem, angle A has to be congruent to angle X. And then we have the familiar angle, side, angle, congruent to angle, side, angle. And the two triangles would be congruent. But rather than go through that step every time of proving A congruent to X by no choice, we just do it by this new theorem, angle-angle side, and save ourselves the step of using the no-choice theorem. However, we'll see in certain instances later in the year that no choice is a pretty valuable theorem because it even works when the triangles are not the same size. So it'll come up again in chapter 8. Okay, please go back and take any notes on anything you had trouble with. Come in with questions tomorrow for class. All right, thanks for watching.